What is going on, guys? My name is Amos and I'm back again with another video. So in today's video, we want to look at a few integration problems. So with me here, I have 5 exercises and we want to employ the integration by parts formula. Now, let's first of all skim through these exercises that we have here and then we'll start solving these exercises. Now, if you basically observe what is happening here, what we have is a product of two functions. So we have the same thing for the first problem, the second problem, and then the third problem, the fourth problem, and then the fifth problem. Now, each time we see, now it's not very clear that here it's not clear what we're supposed to do here, or that we are supposed to employ the integration by parts formula here, especially for the last one, but then we are going to apply the same method for all the 5 exercises. All right, so without further ado, let's get started with the first exercise, right? So the first exercise here is saying, so we have to evaluate this particular problem. So we want to find the integral of the product of two functions. So we have x and then multiplied by e to the power 2x dx. Now I'm going to say it again. Each time we see a product of two functions, where it's actually a good time to employ the most awesome integration by parts formula. Now let's look at how we can apply the integration by parts formula and try to solve as we try to solve this particular problem, right? So we know that, let's first of all remind ourselves of the integration by parts formula. Now the integration by parts formula says that the integral of the product of two functions, now we're going to make the assumption that these two functions all depend on the same variable, which is going to be t. So the integral of the product of the two functions u of t multiplied by v of t is basically going to be equal to u, and then to cut down so that I don't write a lot of things here, I'm just going to say u multiplied by v, and then minus the integral of u of t, and then multiplied by v of t, like so. Sorry, here we're supposed to have u and then v prime here, and then here we're supposed to have u prime and then v, right? And then dt, like so. Then we also have to put the dt here, like so. So the integral of a product of two functions that depend on the variable t is basically going to be equal to this formula. Now this is known as the integration by parts formula, right? And then here we see that our functions depend on the two functions depend on the variable x, but then we can also use t or use any other variable we want to use, and that is not going to change the state of the problem, because they are all going to be variables, right? So what we're going to do now is that we're going to apply this formula. So we have to, so here we're going to say let u of t be equal to, now here we're supposed to say u of x because the function here depends on x. So here we're going to say let u be equal to x, and then we're going to say v prime, then we're going to say v prime is going to be equal to e to the power 2x, like so. And then we know that u prime is basically going to be, well, the derivative of x is going to be 1, and then the integral of e to the power 2x is basically going to be, now v is going to be equal to 1 divided by 2 e to the power 2x. Now if you guys are lost and don't know where this is coming from, now remember that the integral, maybe let me also write it in a different color. So remember that the integral of e to the power ax is basically going to be equal to 1 divided by e to the power ax. So this is what I've applied to get what I have here. Now let's try to now substitute everything that we found here. Let's try to inject it into this particular formula, and let's see what that is going to give us. So what we have here is the integral of, and let me revert to my original color, and then the integral of x, and then e to the power 2x, and then dx is basically going to be equal to, now u multiplied by v. Now my u is x, and then my v is 1 divided by 2 e to the power 2x, and then what we're supposed to have here is 1 divided by 2, and then x, and then e to the power 2x, like so, and then minus, and then the integral of, now u prime. Now I'm supposed to write this prime here so that everything makes sense, right? So the prime has to be here, like so. And then we know that our u prime here is 1, so we're not going to write the 1 here. We're just going to magically put it in our heads that we have the 1 here, And then what is our v? Our v is going to be 1 divided by 2 e to the power 2x. Now, look, the 1 divided by 2 here is a constant, so we're going to take it out of the integral, and then we're going to have 1 divided by 2, and then here we have e to the power 2x, and then we have dx, like so. And then if we continue and solve, we're going to have 1 divided by 2x, and then e to the power 2x, and then look, what we have here is in the form e to the power, the integral of e to the power ax, and then the result here is going to be 1 divided by 4, because we're going to have an additional 1 divided by 2 that is going to multiply with this 1 over 2 that we have here. And then we're going to have e to the power 2x, and then plus the constant of integration. So this is going to be it for the first exercise, and then let's now go to the second exercise and try to solve it. Right, so for the second problem, so we basically have the same structure. So what we're seeing here is a product of two functions. We have root of x, and then we have the natural log of x. So we want to find the integral of this product of functions. So again, we need to choose our u, and then we also need to choose our v prime, right? So let me first of all write the formula. So that's the first thing that we are supposed to do for any problem. We basically first of all have to write the formula so that we have it in mind. So we know that the integral, I know that we are supposed to we're supposed to assume that the functions depend on some variable or some parameter t, but then I'm just going to like shorten everything and just put u, the integral of u v prime. Let me first of all check what I wrote here to just make sure that everything is okay and right and consistent. So we have u v prime is going to be equal to u multiplied by v, and then minus the integral of u prime and then v. And of course you can put your dt here, but then I'm just going to shorten everything, right? And then u here is going to be, we're going to say u is going to be equal to ln of x. Now at the very end of this video, I'm going to give you like something that is going to help you choose u, that is going to help you make the best choice for you. Of course, you can be anything, can be any function, can be any of the two functions, and then v prime can also be any of the two functions. But then I'm going to, sort of like provide you with something that is going to help you remember like what is going to be the best choice for you. And then here we say u is going to be equal to ln of x, or natural log of x, and then v prime is going to be equal to root of x. And then here, our u prime is going to be equal to, so here, our u prime is going to be equal to, so well, what is the derivative of natural log of x? Well, it's basically 1 divided by x. And then you can also put a dx here, because we're differentiating with respect to x, but I'm just going to leave it the way it is. And then the integral of this is, well, you can basically write this as x to the power 1 divided by 2. So what we do when we're integrating is that we add 1 to the current power and then divide by the new power, right? So if you do that, you're going to get 2 divided by 3, and then x to the power 3 divided by 2, right? So I'll give you some time to verify, and then of course you can pause the video and then come back and then continue watching, right? So if we inject everything that we found into this particular problem, what we see here is that the integral of the root of x and then natural log of x is going to be equal to, now our u is natural log of x, but then our v here is 2 divided by 3 x to the power 3 divided by 2. Now if I write everything, we should have 2 divided by 3 and then x to the power 3 divided by 2, like so, and then the most awesome natural log of x, and then minus the integral of now our u prime. Our u prime here is 1 divided by x. Our u prime is 1 divided by x, so I'm just going to put it here. So we have 1 divided by x, and then our v is 2 divided by 3 x to the power 3 divided by 2. Now 2 divided by 3 is a constant, so we're going to take it out of the integral, and then we're going to write it here. And then now this 1 divided by x is going to multiply with this x to the power 3 divided by 2. Now I'm just going to simplify in advance here, then I'll give you some time to verify, and then once again pause the video and then check that everything is okay. And then what we're going to have is x to the power 1 divided by 2 and then dx, like so. All right, so pause the video, verify, and then continue watching. So here we're going to have 2 divided by 3 and then x to the power 3 divided by 2, and then natural log of x, and then of course I can write that a little bit better, and then natural log of x like so, and then minus, and of course this is going to give us another 3 divided by 2 as the power, and then divided by 3 divided by 2. And then of course if you sort of like write everything properly and then try to multiply the terms, what you get at the end is going to be 4 over 9, and then x to the power 3 divided by 2, and then plus the constant of integration. Then I'm also leave you some time to basically verify and check that everything is okay and then now if you're now happy with everything, we can now move to the third problem. All right, so for the third problem, we have the integral of we want to evaluate the integral of t squared multiplied by sine beta t, where beta is just some real number, and let's see what this is going to give us. Okay, so now again we need to choose our u. So I'm going to say, now we first of all have to write the formula. So the integral of u v prime is going to be equal to uv minus the integral of u prime v, and then here u is going to be equal to t squared, and here we say u is going to be equal to t squared, and then v prime is going to be equal to sine beta t like so, and then our u prime is going to be equal to 2t, and then our v is, now let me just remind you that the integral of sine alpha t, where alpha is some constant with respect to t, is going to be equal to minus 1 divided by alpha, and then cosine alpha t like so. So if we apply that here, we must get minus 1 divided by beta, and then cosine cosine beta. Now instead of alpha, we're supposed to put beta because beta is the constant we have in this particular problem, and then cos beta t. Now let's try to apply everything that we have here. We try to inject it into this formula. So the integral of t squared and then sine beta t is going to be equal to, now I'm going to put dt here, is going to be equal to u multiplied by v. Now u is this function, and then v is this function. So we're going to have minus 1 divided by beta, and then t squared, and then cosine beta t, and then cosine beta t, and then minus, and then here we're supposed to have the integral of, then here we have u prime v. Now u prime is 2t, all right, u prime is 2t, and then v is minus 1 divided by beta, and then cosine beta t. So what we have here is we have a minus here. So when we take it out of the integral sign, it's going to multiply with this minus, the minus 1 that is outside. So we're going to have a plus, and then the 2 divided by beta is going to be a constant. So I'm going to write it here, and then inside we're going to have t, and then multiplied by cosine beta t like so. So here we are supposed to apply another integration by parts. So before we sort of like maybe simplify things here, what we're going to do is I'm going to call this a, and then I'm going to evaluate. Then a here is equal to the integral of t, and then cosine beta t like so. And then of course here we're supposed to do the same thing. We're supposed to choose our u, and then we're supposed to choose our v, and then our v prime, our u here is t, and then our v prime is cosine beta t, and then our u prime is 1, and then this is going to be v prime, and then our v is going to be, now let me just remind you that the integral of cosine beta t is going to be equal to 1 divided by beta, and then sine beta t like so. So here if we apply that here, we're going to have 1 divided by beta is going to be equal to sine beta t like so. All right, so this is what we have. Now let's continue with our calculation, and then now if we inject everything here into if we use our formula, we're supposed to get that a is going to be equal to, now let me just scroll up and maybe look at the formula, and then let's now inject. So u multiplied by v, so u multiplied by v is t multiplied by t divided by beta like so, and then we have sine beta t, and then of course we are supposed to have minus, and then the integral of u prime v. Now u prime is 1, and then v is 1 divided by beta sine beta t. So what we're going to have here is 1 divided by beta, which is a constant, so I've taken it out of the integral sign, and then we're supposed to have the integral of beta t, like so, right? So that looks good. So then we continue with our our evaluation. So we have a is equal to t divided by beta, and then sine beta t, right? And then we have sine beta t here, sine beta t, and then the integral of sine beta is going to give us a cosine. So we're going to have a cosine here, but then the cosine is going to come with a negative, and so we're supposed to have plus 1 divided by beta squared. All right, so we're going to have a minus 1 over beta in front, and then we're going to have the cosine beta t, like so. So that is our a, and then now let's inject everything into what we have here. All right, so let me just scroll down a little bit, like so, and then let's now substitute, and then the whole thing is going to be now t squared, and then sine beta t, and then dt, and then this is going to be equal to minus 1 divided by beta, and then t squared, and then cosine beta t, and then plus 2 divided by beta, and then multiplied by whatever a is. So a is t divided by beta, and then sine beta t, and then plus 1 divided by beta squared, and then this is cosine beta t. And of course, I'm going to expect that you guys are going to know how to sort of like multiply things, and then this is going to basically from now what follows is extremely easy. You just have to distribute this 2 divided by beta, and then see if you can sort of like simplify a few terms. You can sort of like maybe some terms might maybe add, or some terms might are going to subtract. Now, of course, we've done a lot of work here because we've applied the integration by parts formula 2 times. So I'm just going to give you time to sort of like go through this particular problem, and then if you're happy with everything, let's now look at the next problem. All right, so for the fourth problem, we have the integral of arcsine of x squared and then dx. Now you might not maybe see that we have we have to employ the integration by parts formula, and maybe you might not maybe easily see what our choice of u is going to be, and our choice of our choice of v prime, whatever you might not be fully sure what our choice is going to be. But to be able to solve this particular problem, what we have to do is we're going to take this entire thing as our u, and then dv is basically going to be equal to dx, or 1 multiplied by dx. Okay, is going to be equal to dx. And of course, in fact, for all these problems that we have here, what you can do is to maybe not get confused is, and here you can see that v prime here, I'm just saying it is e to the power 2x, but then what you can do is that you can get everything here, because if you don't want to sort of like maybe conflict, to have conflicting ideas in your head, so you can maybe add the dx here, so that you basically see where I'm going here. Let me just maybe do the same thing for everything that we have here. So I'm just going to basically inject the dx here, so that you don't have conflicting ideas, and of course you can and of course this is going to be dt. So what I'm going to do in this particular problem is I'm going to take this entire trigonometric function or inverse trigonometric function of the function sine x. I'm just going to take it as this entire thing with a squared. I'm just going to take it as my u, and then my v is basically going to be dx, so that you guys do not get confused. So u here is basically going to be equal to arcsine of x, and then squared, like so, and then v prime is going to be equal to dx. Or maybe what you can do here is you can maybe take v prime as 1 if you basically want to maybe forget about the dx, right? If you want to forget about the dx, and then what is our u prime? Well, our u prime is, so we're going to use composite differentiation here. So because we have arcsine and then we have a squared, So what we're going to do is that we're first of all going to differentiate the power. And if we differentiate the power, we're going to get 2 and then multiply it by, and then we write whatever is going to remain. So arc sine of x, we've differentiated the power, and then we differentiate the function that is in the parentheses, which is this function. Now, this is something that I expect that you guys know. Is one of the usual derivatives you guys are supposed to know. Well, the derivative of arc sine of x is basically 1 divided by root of 1 minus x squared. So this is the derivative, and then here we've sort of like differentiated with respect to x, or with respect to x, and that is why I've put the dx, and then the v here is the integral of dx. Well, you guys guessed it, it's x. So even if you put a 1 here, it's still going to be x. So you see why I was maybe leaving out the dx, because what is going to be done, what has to be done is sort of like clear, as something that is easy to spot, easy to you cannot confuse things like that. So I was just maybe cutting down on the amount of writing I was doing, right? So this is what we have. So what we're going to do is we are now going to sort of like write everything. And of course, I did not write the formula here, but then we've written it 2 times, and I'm sure that everything is okay. And so the integral of of the function arc sine of x and then squared and then dx is basically going to be equal to, now if I allow myself to write everything, we're going to get x and then arc sine of x and then squared and then minus 2 and then multiply. Well, 2 is a constant, so we take it out of the integral, and then we have x and then multiplied by arc sine of x, and then we're basically going to divide this by root of 1 minus x squared, right? So now this looks very, very complicated, but then to be able to maybe simplify this particular thing that we have here, I'm just going to call it b. And then to be able to simplify our b here, we're supposed to use another technique, which is going to be change of variables. We need to change our variables. Now, this is something that might be totally new to you. If maybe this is the first time you're hearing, maybe you're hearing, changing variables to be able to simplify the expression that we have, under the integral sign. So this might be a little bit confusing, but you guys have to bear with me. But I'm going to try to the best of my ability to sort of like explain everything in a very, very easy way that you are going to understand. But then the focus of this video is going to be the integration by parts, applying the integration by parts formula. But then we are supposed to simplify this very, very weird expression. And then we're supposed to use a change of variables. So all we have to do here is, let me just first of all write. Now we have our b is x. And then here we have, arc sine of x, and then divided by root of, and then 1 minus x squared, and then dx. So let's maybe put the dx here, like so. And then here what we're going to do is that we're going to pause. So we're going to say let, maybe let's say p, let p be equal to, arc sine, be equal to arc sine of x. So if p is equal to arc sine, if p is equal to arc sine of x, then what is going to be dp? So here dp is basically going to be equal to, well, you guessed it right, it is 1 divided by root of 1 minus x squared. Now, of course, to get that correct, so it's 1 minus root of 1, it is 1 divided by 1 minus 1 minus x squared, and then here we differentiated with respect to x. So here, since we have dx and then we're changing variables, we're supposed to make dx the substitute formula, so that we sort of like get rid of it in this integration that we are performing here in b. So here we see that dx is basically going to be equal to 1 minus, now what we can do is that we can try to write that a little bit better. So this is going to be 1 minus x squared, and then maybe let's put this in parentheses and then multiplied by dp, like so, right? So here, if p is equal to arc sine of x, then this is going to mean that x is basically going to be equal to sine of p. All you can do here is apply the sine on both sides of the equation, and then this is what you're going to get, because arc sine is basically the inverse function of sine. or the inverse mapping of the trigonometric function sine. And of course, what's funny is that whenever you're talking about these inverse functions, you always have to be very, very specific about the interval we're talking about. But then we're going to leave all that, and then what we're going to say is the sine function is basically the inverse of the sine function. So we have everything we need to basically sort of like simplify this expression here. So if we now change, we're going to have that this integral and then x, or x is equal to sine p. So we're going to have sine p, like so. We're going to have sine p, and then what is arc sine of x? So here what we have arc sine of x, right, which is okay. Now arc sine of x here is p, so I'm going to put the p in front, like so. And then what is our dx? Well, dx is equal to this expression that we have here. So we see that this and this are going to simplify, and then finally we're going to get dp. Now check it out. We have a very simple function, and then now we can now apply our integration by parts. And if we apply our integration by parts, now of course we know that our u is going to be equal to p, and then our v prime is basically going to be equal to sine p. And because I want to be consistent, now I'm going to say dp, and then u prime is going to be 1, and then v is basically going to be equal to minus cosine p, like so. Is going to be minus cosine p dp. And then now what we're going to do is we're going to sort of like put everything into one formula, and then we have that the integral of p and then sine p dp, of course. Let me just get rid of that. Sine p and then dp is basically going to be equal to minus, it's going to be equal to, because it's u multiplied by v, so we're going to have minus p and then cosine p, like so, and then plus, and then the integral of cosine t dt. So where is the plus coming from? So we have here, we're supposed to have u prime multiplied by v. Now u prime is 1, and then v is minus cosine p. So the minus 1 is a constant. We take it out of the integral sign, but then there's a minus here, so we get a plus. So here we have cosine t and then dt, and then plus the constant of integration, right? Plus the constant of integration, but we're not going to add it yet. Well, we actually can. We're not yet done with integration. And then finally, what we must have is minus p and then cosine p, and then plus. Now the integral of this is going to be sine p, and now of course here it's p and not t, right? So I mostly use a t. That's why I had this confusion. And then plus the constant of integration. So we have b. We now have b, right? We now have b. Then all that is left to do is to sort of like now write everything. All we have to do now is to write everything so that we can sort of like have one single answer. So let's now copy everything. So finally, so maybe here we can say finally, like so, that the final answer is going to be equal to, maybe so that we don't write a lot of things, what we can do is that we can say that this is equal to I. So now finally we can say I is going to be equal to, finally, and then I is going to be equal to x multiplied by arc sine of x squared, like so, and then plus, and then let's check what we have here. So what we have here is minus 2 and then multiplied by b. So minus 2 multiplied by b, right? So we can maybe get rid of this. And then here we have minus 2 multiplied by b. And then what is our b? Our b is this function that we have here. Our b is sort of like this function that we have here. And then this is going to be equal to x, and then arc sine of x squared, and then minus 2, and then b is minus p, and then cosine p, and then plus sine p plus c, like so. And then maybe we can say x, and then we have arc sine of x squared, and then plus 2, and then p, then cosine p, and then minus 2 sine p. And of course you can sort of like have, you know, minus 2, like so. But then what I want to do here is, you know, sort of like get rid of this constant and then plus c, like so. All right, because it's going to be a constant. After all, it's going to be a constant. Or maybe what we can do is we can leave it the way it is. We can leave it the way it is. Maybe so that I do not confuse anyone here. What we can do is we have minus 2 multiplied by this, and then plus sine p, like so. And then we put the plus c, like so, and then minus 2, and then multiplied by sine p, and then minus 2 multiplied by c, like so, minus 2 multiplied by c. And then if you want, you can say that this is some constant k, like so. This is some constant k at the end. And then this is going to be our final answer for the for this particular problem. And then let's look at the fifth exercise. Solve the final problem. So for the final problem, we have the integral of natural log of root of x. Now you can first of all maybe start by saying that, you know, natural log of root of x is equal to, we can say that natural log of, you know, root of x is going to be equal to 1 divided by 2. We can, you know, use the laws, you know, that we the laws of logarithms, and then we can have, maybe we can have here 1 divided by 2, and then we can have ln of x, and then you can sort of like solve the problem, right? But then I'm going to solve it in a different way so that I, you know, maybe help you and sort of like reminding you of maybe the other things that you might have forgotten, things that are not so trivial, things that, you know, cause a lot of problems. So I'm going to I'm going to now adopt a different approach. But then this is possible. You can first of all start with this and then try to see how you can solve the problem. So I'm just going to take a different approach to remind you of the other things that are non-trivial. So what we're going to do is we're going to say u is going to be equal to natural log of root of x, and then our v prime is going to be equal to dx. Once more, our u prime is going to be, now to differentiate what we have here, natural log of root of x, we basically have to look at it as, you know, some form of function composition here. So I'm going to maybe put this in parentheses. So first of all, start by differentiating, you know, what is inside with respect to x. Well, the derivative of what is inside with respect to x is, now remember that here we have, you know, root of x is equal to x to the power 1 divided by 2. Now, if we want to differentiate this, then we basically have to differentiate this. So to differentiate this, we're going to have, you know, 1 divided by 2, and then here we're going to have divided by, you know, root of x. Why do we have this? Because this is going to be 1 divided by 2, and then x, and then 1 over 2, and then minus 1. And then this is going to give us minus half. But then to get rid of the negative, then the x is going to come down. Then you multiply it with the 1 divided by 2, so you get 1 divided by 2 multiplied by root of x. And then we now differentiate ln of x. So if we differentiate ln of x, we know that ln of x is, we now differentiate ln of what is inside. Now we know that ln of x is 1 divided by x. So this is going to be 1 divided by root of x, and then multiplied by this item that we have here. So multiplied by 1 divided by 2, and then root of x. And then now the integral of v prime in this case is going to be x. So the integral of the x is basically going to be x. And so maybe I'm just going to call this integral j, so that we don't write a lot of things. So in this particular case, j is going to be, you know, x multiplied by, you know, ln of root of x, because it's u multiplied by v, and then minus then the integral of, now it is going to be u prime multiplied by u prime multiplied by v. So u prime is this quantity multiplied by this quantity. So we have x divided by root of x, like so, and then multiplied by, and then 1 divided by 2, and then multiplied by root of x. So here we have root of x. So if we simplify, you know, a little bit further, we're going to have natural log of x, x multiplied by natural log of root of x, and then when the root of x multiplies with this root of x that we have here, we're going to get x, then the x and the x simplify. So finally what we get is 1 divided by 2, and then dx. I'm going to put the x here, and then this is going to be equal to x, and then, you know, ln of x, and then the 1 over 2 is a constant, so we're going to have minus 1 over 2, then the integral of the x, which is basically going to be x. So the final answer is x multiplied by ln of x, and then we have minus 1 over 2, and then 1 over 2 multiplied by x, and then this is going to be plus the constant of integration, which is going to be c. Now, let me just give you something that is going to help you remember some of the techniques to apply when it comes to this integration by parts. Right, so let's look at this bonus section where I'm going to sort of like guide you on how to like make the best choice of u. So what we're going to do is that if you're given a product of functions and then you're taught to integrate, and then you want to make a proper choice of u, you basically have to look at these things that I've written here. So if you have these things, so the precedence here is increasing from starting from the bottom and then going to the top. So meaning the logarithmic function, if you have a product of functions, then the logarithmic functions is going to have a higher precedence. So maybe let's say you have x multiplied by natural log of x. So what you want to do there is to let u be equal to log of x, okay, natural log of x, and then v prime is going to be equal to x. So because the logarithmic function has a higher precedence. Now, unfortunately, in this video, we've not looked at any inverse trigonometric function. We've looked at one. We've looked at the arcsine function, which is going to be the inverse of the sine function. So that has a higher precedence as well. But then its precedence is lower than the logarithmic function. So if you have a logarithmic function and an inverse function, and then you're taught to integrate the product of these two functions, then you want to choose u to be the logarithmic function, and then the other part to be the inverse trigonometric function. But then if you have something, let's say you have the inverse trigonometric function and then an algebraic function like maybe t squared or x squared or anything like that, then the inverse trigonometric function has a higher precedence. Okay, so anything that is up on the list has a higher precedence, and then that is the choice that you're going to make. Algebraic here is maybe something like root of x, t squared. And then if you basically look at how we've solved these particular problems, you basically see that these I actually had this in mind. You see that we've respected everything that we've written here. All right, thank you guys for watching, and as usual, this video is going to be, this PDF document is going to be in the description. I'm also going to put in the description a document that is going to have the usual trigonometric functions, usual derivatives of functions, and then there's also going to be a document that is going to contain the usual integrals, so that you guys can master them and try to sort of like put them in your head, so that you don't have to sort of like all the time rederive them and then maybe you start solving your problems. Otherwise, thank you for watching. Be sure to give me a like if you like the video, and please subscribe to my channel. And I'll see you guys next time.